Right, so this is the first video on covalent bonding. It might be the only video on covalent bonding. I don't quite know how long it's going to take me to get through. Anyway, you need your periodic table out in front of you because I'm going to make references to that. And hopefully you already know that a covalent bond exists between the atoms of two non-metals. And it's formed when you share a pair of electrons between the atoms of these two non-metals. And this pair of electrons is attracted to the two nuclei, in other words the nucleus of each of the two atoms there. So the definition is the strong attraction between the bonding pair of electrons and the nuclei of the two atoms. So to show you the bonding in a cross and dot diagram, I'm going to pick on hydrogen first of all and the molecule H2. Now if you find hydrogen in the periodic table, it's right at the top, and you can see from its atomic number that it only has one electron in its outer shell. Here's that electron. Now the max number of electrons an atom of hydrogen can have in its outer shell is 2. And when it has 2 electrons, its shell is full, complete, and therefore hydrogen, if you like, is happy. Okay, it's stable with 2 electrons in its outer shell. And it achieves this by sharing a pair of electrons with another hydrogen atom. So the two atoms get very close to each other and then they share their electron pair. So we put the electron pair in the middle and we do what's called a cross and dot diagram, or some people call it a dot cross diagram, it doesn't really matter. But one electron is a cross, and that shows it's come from a different atom than the electron which is a dot. So each atom contributes 1 electron. Now if we have a look at a chlorine molecule, Cl2, find chlorine on the periodic table. Hopefully you should see that it's in group 7. And as it's in group 7, that means that you effectively have 7 electrons in the outer shell. And notice that I pair my electrons up when I draw them, and here's the 7th. Now chlorine, it's a slightly bigger atom, and the maximum number of electrons chlorine can fit in its outer shell is 8. So again, this chlorine atom is 1 electron short of being happy. So what it does is it gets that electron by sharing a pair with a neighbouring chlorine atom. So there's the electron that it's acquired effectively from this new atom here, and this new atom originally had 7 electrons. And there's the 7th. So now if we count round, 2, 4, 6, 8. This chlorine atom is happy. 2, 4, 6, 8. This chlorine atom is happy. And when we form a covalent bond, we bring 2 atoms together, or maybe 3 atoms or 4 atoms if we're forming more than one covalent bond. This is what's called a molecule. Overall, it doesn't have a charge, and it's 2 atoms covalently bonded together. Now you'll notice that we formed here covalent bonds between 2 identical atoms. Covalent bonds don't always form between 2 identical atoms. So for example, hydrogen chloride. Now hydrogen chloride is HCl. Hydrogen, we've already seen, has 1 electron in its outer shell. Chlorine actually has 7 electrons in its outer shell. So what actually happens is I'm going to draw chlorine first of all. There is my 7th electron. How do you think chlorine could acquire 8 electrons in its outer shell? The answer to that is it picks up that extra electron from the hydrogen. So we form a covalent bond with the hydrogen. Chlorine now has a full outer shell, 8 electrons. Hydrogen also now has a full outer shell. Hydrogen only requires 2 electrons for a full outer shell. So that's a stable molecule with one covalent bond. And sometimes we might draw it as H-Cl, just to show hydrogen and chlorine have been bonded together. Moving forward, things I'm afraid do get slightly more complicated. We'll have a look at water, H2O. Now, in water, the oxygen here, and I'm just drawing the outer shell of the oxygen, so I'll just write O. Find oxygen in the periodic table. It's in group 6. So that tells you it has 6 electrons in its outer shell. There's the 6 electrons. It obviously wants 8 electrons in its outer shell. So really, it's desperate for another electron there and another electron there. And hopefully you're thinking, right, that's quite easy. It gains it from the hydrogen. So here's my hydrogen bond there and a bond there. So oxygen has got 8 electrons now. Hydrogen has 2 electrons, and we've now got a stable water molecule. Methane, CH4. We'll start with carbon. Carbon is in which group? Find carbon on the periodic table. It's in group 4. It tells you we've got 4 electrons in its outer shell. 1, 2, 3, 4. It's going to bond with hydrogen. It's going to bond, we're telling you it bonds with 4 hydrogens. And hopefully you're already picking up on the fact that the bonds, well, if we put one there, carbon now has 5 electrons. We put one there, it now has 6 electrons in the outer shell. Hydrogen, 7 electrons. We put one there, 8 electrons. And therefore your carbon has completed its outer shell. It's met its life goal. Ammonia, very similar to methane, NH3. It's made in a process known as the Haber process, which you look at in your second year of your GCSE course. We'll start with the nitrogen atom. Now nitrogen is in group 5. Now hopefully you're already picking up on the fact that group 5 means 5 electrons. So there's 1, 2, 3, 4, 5. It's bonded to 3 hydrogens. Surprise, surprise. Oh look, these 3 here are unpaired. And that's your complete cross and dot diagram. Notice the shared pair of electrons which are attracted between the nucleus of the hydrogen and the nucleus of the nitrogen. And because only a pair is shared between that nitrogen and that hydrogen, that is what we call a single covalent bond. It is actually possible to form a double covalent bond, and that's what happens when we form an oxygen molecule, O2. An oxygen atom has 6 electrons in its outer shell. How do I know this? Well, because I can look at the periodic table and see that oxygen is in group 6. So that immediately tells me it's got 6 electrons in its outer shell. Now, if it's got 6 electrons in its outer shell, how many electrons does it need to gain in order to fill its outer shell? Well, it really wants 8 in the shell. It's currently got 6, so it needs to gain 2. Now that tells me that oxygen needs to form 2 covalent bonds. And as it actually just bonds to itself, that means instead of forming 1 bond to itself, it must form 2 bonds to itself, a double covalent bond. So let's draw on my your electrons of the oxygen at the start. 1, 2, 3, 4, 5, 6. There's an electron from another oxygen. There's an electron from another oxygen. There's my other oxygen atom. Now we've got 2 pairs of electrons being shared, and now of course we need to put the electrons on the second oxygen atom. We've already given it 2. It started with 6, so 4, 6. And now we count up round. 1, 2, 3, 4, 5, 6, 7, 8. So that atom is now happy. The one on the right, 2, 4, 6, 8. The atom on the right is now happy. Of course, it's good practice to put the symbol of the element there. And earlier I said that we could put a dash between the 2 atoms if we were writing this out very quickly to show a single covalent bond. This time, rather than putting a dash, we put 2 dashes between them to show the double covalent bond. Now oxygen is just a start really with the double covalent bonds. Nitrogen, a little bit trickier, N2. Nitrogen is in which group? Find it on the periodic table. It's in group 5. So that tells you that the nitrogen has 5 electrons in its outer shell. It needs to gain 3 by bonding effectively to itself, which tells you that actually you form a triple covalent bond. And I'm just going to use a different colour because it makes it easier to see, or hopefully will do. So I'm drawing this in a slightly different way than I've drawn the previous ones, and I hope that doesn't confuse you. I've drawn the bonds in first, and this is nitrogen over here and this is nitrogen here. And I just said a couple of moments ago that nitrogen's in group 5, so it has 5 electrons. So let's take the atom on the right, which I've said is the crosses. Okay, 1, 2, 3, 4, 5. And the atom on the left, 1, 2, 3, 4, 5. So it's still got the same number of electrons that it had at the start, but it's gained those 3 effectively by sharing them with the other nitrogen to form a stable molecule. And instead of drawing 2 lines to show a double covalent bond, this is a triple, so we draw 3. And actually this starts to show you some very important chemistry about these molecules. A triple covalent bond is very strong, but it also shows you that you've got a pair of electrons not involved in the covalent bond, and that gives nitrogen some very interesting chemistry. Final one on this video we're going to do is carbon dioxide. Now carbon is in group 4. You can find it on the periodic table. So it has 4 electrons. Oxygen, well, we've got 2 oxygen atoms. Here's 1 oxygen atom, here's a second oxygen atom, and oxygen is in group 6. It has 6 electrons. So we have to work out how to combine carbon and the 2 oxygens in order to make them effectively happy, in order to give them both complete outer shells. And so what happens is you form a double covalent bond between the carbon and the oxygen, and a double covalent bond between this carbon and this oxygen here. So this pair, or these 2 pairs here, form a bond, and these 2 pairs here form a bond. Now that's not a very good drawing at all, is it? That doesn't show it very clearly. So let's draw the carbon again, and let's have the electrons that are going to be bonded on either side. And then let's draw our oxygen. Here's my other oxygen. And now let's pair those electrons up with ones from the oxygen. Then we've got pair, pair. And again count up just to make sure my oxygen has the number of electrons it started with. 2, 4, 6. Then plus the 2 new ones effectively gives it a complete outer shell, 8.